students of the day. I am Dr. Vaibhav Jain, Student Branch Advisor, ASHRAE, Student Branch, Maharaja Agrasen Institute of Technology, Delhi, India. First of all, I express my sincere gratitude to ASHRAE for recognizing our project Air Conditioner Cum Air Sterilizer for combined applications of air heating and cooling for the presentation in Winter Conference scheduled in Las Vegas in this January. My best wishes to the organizing team, and I wish to congratulate ASHRAE for organizing this beautiful conference. It is really a splendid event both in terms of intellectual quality and social gratification. Now, coming to the project, I am thankful to ASHRAE Society for providing us the grant of $4,980 under the Project Equipment Grant Scheme to work on this project. I, with my students, are here to present to you the basic understanding of our proposed project and what we have done till now and will do in the near future, and how we are on the track towards its completion. The ASHRAE student members of MAIT are involved for the fabrication of this test facility, and work is divided so that every student member is able to learn and understand the process of fabrication closely. Now, my student will demonstrate you how the work is going on.
My team includes a total of 11 members. Now, one by one, my team members will give you a brief overview of what we have done so far and what we will be doing in near future.
In modern engineering, HVAC systems play a huge role in maintaining air quality and desired temperature of the specified area. The system is a demonstration of air handling unit, AHU, which is responsible for cooling or heating purpose along with maintaining air quality through the use of filters and UVC emitter. The proposed system is capable of controlling indoor air quality index AQI, and it is power efficient as well as has a negligible impact on the environment in comparison to vapor compression refrigeration systems. In this project, an experimental test facility of the air handling unit is designed, developed and fabricated by a project team.
As you know, health is one of the greatest concerns in today's era. There are many types of things which affect our life, like pollution, COVID-19, etc. As the pollution keeps on increasing day by day, and moreover, it is a global problem. Here in India, the urban areas like capital Delhi are usually more polluted than the countryside. The air quality index of Delhi is unhealthy, due to which people are suffering from various kinds of diseases. I would like to tell you that the 30-day average of capital's air quality index stood at 376 in last November, which comes under hazardous category. Generally, an AQI between 0 to 50 is considered good, 51 to 100 is satisfactory, 101 to 200 moderate, 201 to 300 poor, 301 to 400 very poor, and 401 to 500 are marked as severe or hazardous. To prevent our health and maintain the good AQI, people can use our proposed setup, which is capable of controlling indoor AQI, and it is power efficient as well as has a negligible impact on environment.
The next motivation which led us towards this project is the climate of our country, especially the capital city Delhi. In Delhi, spring season is in February and March, having warm days with low to moderate humidity. Summer season is in April and May, having hot to very hot days with low to moderate humidity. Monsoon season, which is the rainy season, is in June, July, August and September, having hot days to high to very high humidity. Autumn season is in October and November, having warm days with low humidity. Winter season is in December and January, having cold days, cold nights with moderate humidity. The above weather condition needs an all-year air conditioning system which can provide comfort air with desired temperature and can control the humidity. The next problem which led us towards the development of this system is the global pandemic COVID-19. Since COVID-19 affects our life badly, we require the air sterilizers to protect ourselves from the viruses like COVID, which has affected the life of all the individuals across the globe.
Keeping these problems in mind, we come up with an idea of Air Conditioner Cum Air Sterilizer. This proposed system is a demonstration of air handling unit which will be responsible for cooling and heating purpose along with maintaining air quality through the use of pre-filter and HEPA filter, removing bad odors by using carbon activated filter, and also kills microorganisms using the UVC emitter. It is also capable of killing COVID viruses, thus can be of much need in these worsening COVID situations.
The system works on the application of psychometric processes. It says that it is possible to control the outlet conditions of air by controlling the supplied water temperature externally and hence obtaining cooled or heated environment in the desired space. The outside air will be sucked by the blower or exhaust fan. It will pass through pre-filter where the particles of around 10 microns will be filtered out. HEPA filters will remove particles bigger than 0.3 microns from the air. After passing through these filters, bad odor will absorb by the carbon activated filter. Now the outside air will be sterilized.
After the purification, cooling or heating will take place according to the summer or winter season. For heating of the air, steam will be injected and will be in direct contact with the cold air. Heat transfer will take place between the air and steam and hot air will be obtained. For cooling of air, in this method, a separate vapor compression refrigeration system will supply cold water at desired temperature, which will be flowing with the help of honeycomb structure, resulting in cooling of air. After the cooling of air, dehumidification will be done with the use of an eliminator. Then in the exit duct, UVC emitters are present. Ultraviolet germicidal irradiation is a disinfection method that uses short wavelength ultraviolet light to kill or inactive microorganisms by destroying nucleic acid and distributing their DNA. UVC emitter will work along with the reflecting surface to kill the microorganisms.
So let us discuss about the various components of air conditioner cum air sterilizer. Pre-filter, which prevents or stops the fine particles of size 10 microns to move further in the system. HEPA filter, which we need for particles of size more than 0.3 microns to enter in the system. Carbon activated filter, which traps bad odor from surrounding. UVC emitter to improve AQI and reduce infections. Fan blower are used for cooling and air circulation of centrifugal type of suitable capacity. Monoblock pump is a device in which a common shaft contains the rotating parts. Cooling arrangement and heating arrangement to ensure pure water reaches sprinkles and BCRS with a filter inserted in it. Vibration pad is used for isolating noises and reducing wear and tear. AHU covering, which consists of edges and frames, which is made up of aluminium and mild steel, that is large metal box containing separate ventilator for supply, exhaust heating and cooling coils. Sprinkler used for spray water, made up of brass. Dampers is a movable plate that regulates airflow, and safety switches used for opening and closing a circuit. Cooling capacity of AHU. It consists of VCR system 2TR, hermetically sealed reciprocating compressor 2TR, suitable size condenser coil and water cooled chiller tank. Capillary device, hand shut-off valve and different types of refrigerating charging valve, pressure gauge and section gauge, and HPLP controller. Heating capacity of AHU. Boiler with provision to control temperature of steam and rate flow of steam. Driver side and flexible canvas connection are used for sound dampening. Refrigeration use R410A, which is used as a refrigerant in many air conditioning applications, usually packaged in rose colored cylinders, which does not contribute to ozone depletion layer.
Now we will discuss about the instrumentation that we use during this project. We will use various instruments in the setup to keep a track of required physical quantities. These include multi-point digital anemometer to measure airspeed, cooling water flow meter to measure water flow rate, steam flow meter to measure steam flow rate, multi-point digital hygrometer to measure relative humidity, thermocouple or RDT sensors to measure drawable, digital temperature indicator with multi-channel selector for various point temperature, and digital volts and ammeter to measure power consumption or digital energy meter, digital multi-point air quality sensor to measure quality of air in AQI, reflecting surface to increase UVC exposure, pressure gauge and suction gauge for refrigerant, pressure gauge for air pressure, steam pressure gauge, steam boiler, thermostatic controller, all necessary electrical fittings and controls. In addition to above, the provision for temperature control for steams and cold water, flow meter to record mass flow rate of steam and cooling water, mass flow rate control for steam and cold water for heating boiler is installed. temperatures and RH measurement at entry and exit of all major components, provision to control flow rate of air, water drainage system tank to collect cold water for circulation in mass unit, honeycomb structure to spray cold water, provision to clean maintenance of all sections of duct is also provided.
Now, you will get to see some of the glimpses of our setup. As part of the fabrication process, we have done detailed research and market survey to finalize all the specifications and components used. All the students learned about equipments used in market through the process. Fabrication of the setup has been completed and now we will install various measuring instruments discussed earlier.
Our system is expected to achieve the desired cooling heating effect. Air quality will be maintained by eliminating hazardous elements present in the air with the help of pre-filter, HEPA filter, carbon activated filter and UVC emitter. Different meters and sensors will help in detecting the air and water properties. All the components used in the setup have been finalized based on detailed research and market survey. Fabrication of AHU has been already done, so previously and various measuring instruments are to be installed. Approximately 70% work has been done so far.
We thank ASHRAE for providing us such a great opportunity in the form of necessary funding and to work on this project. Since the start of the project, we are extremely excited and will definitely work as a team to deliver on your expectations through our hard work and dedication. Every year, around 240 students study the course of refrigeration and air conditioning at MAIT. We believe that this project will help them in gaining practical exposure of what they have learned. We are very excited as this project will become a new part of refrigeration and air conditioning lab in our college. Lastly, we would like to thank our student branch advisor Dr. Vaibhav Jain, who has always supported us through this guidance and knowledge. He has constantly motivated us throughout the project. At last, we will thank ASHRAE for providing us with the necessary funds in the development of this test rig. Thank you.